All right, guys, welcome to quarter three of 2021. Get excited, right? So we're going to start this chapter talking about similarity. So I want to review how to solve proportions with you. It's just an important basic skill you're going to need to have. And what I find is a lot of you have been taught something called the chicken wing, which I don't know how else to describe other than the bane of my existence. Okay, so for those of you that are doing the chicken wing, please stop doing the chicken wing. All right, this is not middle school. We use much more mature methods. For example, the flaming dragon of doom. All right, also known as the butterfly method, but not in my class because I'm hard. All right, so here, the flaming dragon of doom. What does that look like? Well, it's actually cross multiplication, right? So here, these two are on diagonals. There's an equal sign in the middle. I'm going to cross multiply them. And then here, these two are on a diagonal, right? And so I'm going to go ahead and cross multiply them. And as soon as like, oh, it looks like a butterfly. Not in my class. It is a flaming dragon of doom, right? Yeah, there's this tail. He's got like spikes on it and stuff. Yeah. It's a super hard dragon. Maybe there's some flames coming out. I don't know. Anyway, irrelevant, all right? So here, I'm just going to go ahead and cross multiply, right? Now, when I cross multiply, a few things that I see from students. Number one, they love to do this, right? This is one of my favorites here. They do x times 21, 21x, and then 7 times 39, which is 200 and, oh, geez, 73, maybe? I don't know, right? And for some reason, they get a fraction, okay? No, do not do this, okay? The reason this is a problem here is because this is an equation. There's an equal sign right here. What that means is you need to continue to preserve equality as you work through this problem. So what I'm saying here is for this proportion, right, that this diagonal will equal this diagonal, okay? So same thing, I'm going to do x times 21. I get 21x. And then I'm going to do 7 times 39. 7 times 30 is 210. 7 times 9 is 63. 210 plus 63 is, in fact, 273. Okay? So again, notice here I've got my equal sign. So I multiplied these two. I got 21x. I multiplied these two. I got 273. Now it's an equation I can solve all day. I'm just going to go ahead and divide each side by 21. Okay, and what I'll end up with here, this won't be too bad, this will be x equals 21 goes into 27. Oh, looks to be about 3 times. No, I'm sorry, 1 time. What am I saying? And then 27 minus 21 is 6, so I get 63. 21 goes into 63 3 times, so x equals 13. All right, so here this is our problem, or our solution, x equals 13. All right. If you want, you can always go ahead and plug it back in. It'll be 7 over 13. And if you reduce this fraction, you'll see it reduces to 7 over 13. But this is the method I want you to follow. All right. Let's talk again why this method is important. Right here, this problem has a binomial. Okay. So what I get a lot of students doing here is I like to go ahead and cross multiply. And they'll go ahead and say, well, I got this cross multiplication thing. I'm going to do 15 times 5. I'm going to get 75. I'm going to do 3 times x minus 1. I get 3x minus 3. No, this is not right. Please don't do this, okay? Take your time, right? Think about what we're actually doing here. Why does cross multiplication work? What I'm actually doing is I'm just doing 2 steps in one, right? If I want to solve this for x, maybe the first thing I do is I multiply each side by 5. These 5s cancel. And then I want to go ahead and get this side rid of fractions, right? So I'm going to go ahead and multiply each side by 3, right? These ones cancel. So you can see I get 5 times 15, this diagonal, and I get 3 times x minus 3, this diagonal. But because it's a binomial, you want to go ahead and put it in parentheses, right? So again, I know it's got a little bit sloppy. Let's go ahead and just restart this one so we can talk about it. So we've got 15 over 3 equals, and we've got x minus 3 over 5. All right, I'm going to do my cross multiplication. Now this time I'm really going to spell it out for you, okay? So I've got here 15 times 5. I'm going to write it out. 15 times 5, right? Use parentheses. And then on this diagonal, I've got 3 and x minus 3. So equals 3 times x minus 3. Okay? Now here's an equation I can solve all day, right? I'm going to simplify the left. 15 times 5 is 75. Over on the right, I'm going to distribute my 3. 3 times x is 3x. 3 times negative 3 is negative 9. Now I've got an equation. I'm going to go ahead. I'm going to add 9 to each side. All right. Whatever I do to one side, I do to the other. Some of you are adding 9 here and then subtracting 9 there. Sloppy. You're better than that, right? So here we get 84 equals 3x. right? And then we go ahead, we divide each side by 3 or multiply each side by 1/3. It's whatever you want to do. I'm fine with either or. X equals, what is that, 28? So x equals 28, right? And again, you can plug that back in and see that it satisfies your proportion. A few other things to note along the way. This is not the only way to solve these problems. I could have also simplified 15 divided by 3 equals 5 to start. No problem. Down here, instead of distributing the 3, I could have divided each side by 3, right? Then 15 divided by 3 is 5 times 5 is 25, right? Again, no problem. There's lots of different ways to do these, but this is what I like. This is what makes students not make mistakes, all right? So no chicken wing. Go ahead and use the Flaming Dragon of Doom when you need to solve proportions, all right? I'll see you guys on Monday or Tuesday. Get excited.